I want to show you some analysis of the cost of these toothbrushes. So I want to start with the spin brush and just remind you that based on our target costing, a retail price of $8.99 at the CVS, at the retailer, a retailer margin of 35%, leads to a wholesale price, or the retailer's cost, of $5.84. With a wholesale price of $5.84 and a manufacturer's margin of 45%, that would mean that the landed cost to Church & Dwight has to be less than $3.21. So now what I want to do is I want to turn to kind of a bottom-up analysis and see if we can get a set of numbers that is consistent with that $3.21 target for the landed cost. And so as when I talked about target costing, we've assumed a duty of 4%, we've assumed freight of 15%, which leads to the implication of a factory price of $2.95. And then we've applied the factory margin of 35%, which leads us to a factory cost of $1.91. That's, in essence, the real cost of making the product in the factory, or it has to be less than that in order for the numbers to work. So then what I did is I basically just divided the elements of the product into these categories: parts, and I included in here both the plastic and the metal custom parts, the motor, which I treated separately, the batteries I treated separately, and the packaging I treated separately. And those are the materials costs categories. I then put in a number for assembly, and then I put in a number for, this is assembly cost, and then I put in here a number for materials overhead and labor overhead. And typically the way that works is most cost models apply some additional factor to the costs of materials to account for the efforts associated with purchasing, shrinkage, inspection, vendor management, those kinds of issues, which tend to be fairly proportional to materials costs. And so what I've assumed here is that materials overhead is 10% of the actual materials cost. Labor overhead is a different matter. This includes supervisory labor, and in the case of China, it includes housing, food, other costs associated with managing the workforce. So, and then lastly, I make some assumptions here about some cost rates. So specifically, I assume that all parts in this product, all custom parts in this product, cost $0.0107 per gram. I actually think, based on first principles, I would expect it to be about 0.01, but in all honesty, I've played with this number to make sure the bottom line came out to be $3.21, so that we could get an internally consistent set of numbers. I assume the motor cost is much higher. In particular, it's 3 cents or $0.03 per gram. And I assume that the cost per battery is about 15 cents. And that's a pretty good number based on my discussions with some people in that industry. I then have to make some assumptions about assembly cost. And in this case, what I do is I take an assembly cost per hour, which in China is about 50 cents per hour, half a dollar per hour. And then I assume that each assembly operation takes about 10 seconds. And that then generates an assembly cost per part, which is simply 50 cents per hour times 10 seconds divided by 3,600 seconds per hour gives a cost per assembly, per part for assembly of 0.00139. And then the assembly cost line item is simply 40 parts times that number equals 6 cents. All right, so by that logic, and I think these numbers, by the way, are really pretty close. The parts in the product are 54 cents. The motor is an additional 54 cents. The batteries, there are two of them, that comes out to 30 cents. The packaging, which I didn't show in the teardown, but which is about 20 grams, is 21 cents. And because there are 40 assembly operations, there's about 6 cents of assembly labor. You then apply materials overhead to all of those materials costs. That's an additional 16 cents. You apply labor overhead to that assembly cost number, and that's an additional 11 cents. And that gives us a factory cost of $1.91. It's worth noting, by the way, that in China, the assembly costs are very small. When you add them with the assembly overhead, with the labor overhead, it's about 17 cents for assembly, which is pretty close to the cost of freight to get the stuff from China to the United States. So that's just as a note on the relative magnitude of these costs. So now let's look at a comparable set of numbers for the Oral-B product. And what I did is it turns out the Oral-B product is actually made in Mexico, and so some of these cost parameters are going to be different. Now we'd want to use the same, I'm going to use the same number for the costs of the parts, and the same number for the cost of the motor, and the same number for the cost of the battery, because those things are based largely on materials, tooling, and the use of equipment, which don't vary much according to geography. But the assembly costs are going to be quite a bit higher in Mexico. In particular, the assembly wage in Mexico is more like $2 an hour, about 4 times higher than it is in China. But because of investments that are typically made in North American factories, the assembly efficiency is a little better, and so the assembly time is probably closer to 8 seconds per part. You also noticed that the Oral-B product was quite well optimized for assembly. There were no little screws, it was all snapped together, and so that, I think, is, if anything, a conservative estimate about how efficient that assembly is. Then the other thing I did was I kept the materials overhead the same, but the labor overhead is quite a bit lower in Mexico, and that's because the workforce doesn't typically live on site, and the workforce is typically a little higher skilled because of the higher wage rates, and so the labor overhead is quite a bit lower. The factory margin we're going to assume is the same, and because the factory is in North America, and it falls under the so-called NAFTA, North American Free Trade Agreement, there are no duties coming from Mexico. As a result, if you plug in the actual weight of the parts in the Oral-B, which is 35 grams for the parts, 15 for the motor, there's only one battery, there's only 8 grams of packaging, and the assembly costs are just 15 parts to assemble. What you get is you get a factory price of, you get actually a factory cost of $1.30, and then with the same factory margin, you get a factory price of $2, and then because there are no duties, and because the freight costs are lower, because all you're doing is trucking from the factory to the distribution center, the bottom up cost for the Oral-B product assembled in Mexico is $2.05. It's, with this internally consistent set of numbers, it's about a third less expensive than the landed cost of the Church & Dwight product as assembled in China. Now, let me make a few observations. The first observation I want to make is that I could, of course, take that same design and produce it in China. And I'd like to show you what happens when you do that. If I take the parameters from production in China and I apply it to the design for the Oral-B cross-action, it's actually more expensive to assemble it in China. It's $2.12 as opposed to $2.05. And the reason for that is that the costs of duty and freight are actually much greater than the savings, or a little bit greater than the savings in labor cost, which are only 4 cents here because of the relative to the spin brush, and only 5 cents relative to the cross-action as assembled in Mexico. So because there's so little labor in the cross-action, the advantages of being in a low-wage economic environment are substantially diminished. And so actually, Procter & Gamble is quite rational by assembling this product in Mexico. The second observation I want to make is the incredible power of excellent design in improving the profitability of the organization. So if you look at this, I think we all agree that Oral-B design is quite elegant and quite efficient. And indeed, the Oral-B, Procter & Gamble, if these costs are internally consistent, and if the margins and cost structure of Procter & Gamble is similar to that of Church & Dwight, then Procter & Gamble is making more than $1 more per unit sold than Church & Dwight is. And that's solely the result of a better product design. Now, the last point I want to make is that design isn't easy, and the fact that the spin brush was first gave Oral-B a huge advantage in that they could start with a huge advantage in achieving a great design, in that they could start with what the spin brush people had done and then look for some improved solutions. So while I do believe the Oral-B design is amazing and great, it is in part the result of having been able to observe what Spin Brush did with that first design.